Some students may choose to start at 11, others may choose to start it at 12, who knows? But I wanted to let you know about that. Any questions before we get started? Objective 1 is due this Sunday night. And that's the one we're going to finish up here, and then I'm going to get into the next objective. But objective 1 will be due Sunday night. So let's take a look. Let me go down to and look at our document. We were going over this document last time. This is the document for objective 1. And I believe we looked at the square root of 48. Did we do this one, the cube root of negative 125? Did we do this one?
We did not.
Okay, that's what I have down in my notes is where we need to start. I just wanted to confirm. So last time we did the square root one, though, I believe, right? We did the square root one? We talked about the square root?
We did the square root of 48.
Yes, okay. And that's the reason why I want to know is because I want to relate it back to this one. So this square root of 48, we use square roots so often, we do not write in the little 2 that goes in that V, that little V piece, that little V part. We don't write that in, but we assume that's what's there. So now we're stepping that up from a 2 to a 3 in this V here. So rather than looking for 2 of the same number multiplied together, we're now going to be looking for 3 of the same number multiplied together. So we're looking for a number, 3 of this number multiplied to give us 125. So we're going to ignore the negative sign for a moment. So we want to break down 125. Certainly 5 goes because it ends in a 5 here. So 125 is 5. You could use your calculator, take 125 divided by 5, and you would get 25. And this 25 we could break down further into 5 times 5. So you're seeing we're getting 3 of the same number. That has to do with this 3. In that V there, it's read cube root of negative 125. Now, do an odd number of negative signs or an even number of negative signs result in a negative sign? So if we have what's the answer to that question? Does anybody want to take a stab? Do an odd number of negative signs give us a negative sign? It has a result?
Yes.
So for instance, if I had a negative times a negative times a negative, would I get a negative number for an answer or a positive number?
That'd be a negative.
Yes. Yeah. So an odd number of negative signs is a negative sign, is a negative number. So it seems that the cube root of negative 125 would be 5. Okay, because for every 3 of the same, we take it out of this cube root has a single one, which would be a 5, but then we have this negative sign to contend with, but I know there's 3 of them. We're working with 3 of them, so we have an odd number of negatives, so I know we're going to have a negative sign right here. Now, we can check that by going backwards. We want to take 3 of these negative 5s and multiply them together to check. Negative 5 times negative 5 times negative 5. Negative times negative is a positive, but we have this lonely negative sign here, so the answer is going to be negative. So when we go back, when we check, we're going to get a negative. And 5 times 5 times 5 is 125. And that is what we were given inside the cube root. Does that make sense? Anybody have any questions on this particular topic? So I don't think they will get too difficult. And honestly, if you want to use your calculator to find that out, that's fine too. I don't have a problem with that. If you want to use your graphing calculator, as long as it's on the approved list that's in the syllabus, that's fine. So let's go on. We want to look at this, and this is kind of, this first objective is kind of a hodgepodge of topics. The second objective is mostly on factoring. So rewrite without parentheses and simplify. So this 6x minus 4 is the base. It's the base of this exponent 2. So this exponent of 2 sits up from the base. This exponent of 2, this 2, it tells us we want 2 of the base multiplied together. That's what it tells us. So we want 2 of this base, 6x minus 4, multiplied together. So we can do that by writing 6x minus 4 times 6x minus 4. It's the same as writing, it means the same as writing it in this form. But this is nicer because what does it tell us to do? It says rewrite without parentheses and simplify. So we need to get started somehow. There's not a nice exponent rule for this. So we take and we say, okay, we want 2 of the base multiplied together. And then we realize, hey, we've got terms are added. I can put a plus sign here. So we really have 6x plus a negative 4, 6x plus a negative 4. So really, we've got 2 terms times 2 terms. And really what we want to do is FOIL. You have to have only 2 terms in the first and only 2 terms in the second to be able to FOIL. Once you add on another term somewhere, you can't do it. So let's FOIL. So FOIL is short for first, outer, inner, last. The first means the first term in each multiplied together. So in this case, the first term in here, in this first factor, is 6x. I put it down there. The first term in the second factor is 6x. So we multiplied those 2 together. First 2 together, 6x times 6x. O for outer. Outer means the ones on the outside. This one and this one, the ones on the very outside. So 6x times a negative 4. 6x times a negative 4. So 6 times a negative 4 is 24x. So that would be minus 24x. Inner, these 2 on the inside. Negative 4 times 6x is negative 24x. Last, negative times negative is positive. 4 times 4 is 16. So you want the last 2 in each. 16. Now we're just going to combine like terms and clean this up. 6 times 6, 36. X times x, x squared. Minus 24x, minus 24x. They're like terms because they have the same variable portion. So we combine those by just working with their coefficients. Minus, let's call this negative 24, minus 24 more is minus 48 of what? Of x, plus 16. I just brought the 16 straight down. Any questions on this particular topic? So it's really important to know how to FOIL so that you can check some of your factorizations and make sure they're correct. And somebody here, if you're having some feedback, if you could please mute your mics until you want to talk to me. That's great. So we're going to start talking about factoring, and we're going to go easy and then build ourselves up. We speak a lot about factoring in this course because we can cancel factors. We cannot cancel terms. So that's why we spend so much time on factoring in a math course, is because factoring allows us to simplify expressions, which allows us then to solve equations and so forth. It's really important. So factor 8y minus 16. Factors are multiplied. Just keep that in mind. Factors are multiplied together. So here's our problem. And what I first look at is this 8 here. And I say, well, this looks like it has a factor of 16, looks like it's divisible by 8. Or it can, another way to say that is, this 16 looks like it's got a factor of 8 in it, that I can write it as 8 times a number. Turns out we can. 16 is 8 times 2. You could always take 16 and divide it by 8 on your calculator to find out what this other number is. So I can write 16 as 8 times 2, and we've got a sign in front of that 8 minus 2. Now we want to look at, we factor out of terms. So we have a term here, 8y, plus this term, negative 8 times 2. Terms are added. So in each term we have an 8. So we want to factor it way out front. And what's left? This 8 out of this term, 8's going way out front, so there's just a y left inside. Out of this term, this 8, it's really plus a negative, but I can sneak up. Subtraction is really adding a negative, so I could say sneak in that plus sign and call it a term. So this is the term negative 8 times 2. So we can take that 8's going way out front. We have a minus 2 left inside. Now we can't go any further because we don't have like a square on that y or a cube or anything. It's really important to check. So if you want to check factoring, you just multiply out. So this is 8 times y minus 2. So we're multiplying here, and what we want to do is we want to distribute. We have multiplication over addition because we really have adding a negative. So we want to distribute the 8 through to check. So we get 8 times y, check. 8 times negative 2 is negative 16, check. So we know we are done, and this is the answer. Any questions on first factoring problem there? Any questions?
I actually do have a question. So where
Sure.
did the 16 go? Like, I'm really hung up on that part.
Where did the 16 go? I broke the 16 down into 8 times 2. So I took my calculator and...
Oh, okay, that makes sense.
Okay, good. That's good. I don't want any little thing to hold you all back. You know, sometimes little things in life, once we figure them out, it's amazing where we can go. So if you have a little thing or a question that you, please ask questions no matter what they are. I don't think about, you know, this person asked me this question and they should have already known that. I don't think like that. I don't want anything to hold you all back. Anybody else have a question on this on this particular problem that we just did? Let me just get caught up with my pages here and see what I've got a printout of this just in case I need it. So I'll go back. Let's take a look at the next problem. So now we want to factor here. We have 2 terms. We have 10a squared, and then we have plus, minus sign adding a negative, so I could sneak that plus sign in there really. And so the other term is negative 25a cubed. So let's factor. Let's break things down. You can break things down. We really didn't need to do it on the last problem because there was not a real reason to do so, although you could write that 16 as 8 times 2. So let's look at this first term. How can we write a 10? 10 is 2 times 5, right? Certainly even, so it's divisible by 2, and you could take your calculator, go 10 divided by 2 and get 5. And then a squared, this exponent of a 2 up here really is telling us how many of this base a do we want to multiply together, and that is 2 of those. So that is really, we write that as a times a. Minus in the middle here. This 25 we can write as 5 times 5. And then this a cubed means we have 3 of these base a's, 3 of these a's multiplied together. So we write that as a times a times a. So let's look at each of these terms here and see what we can factor out. What do they have in common? There's a 2 here, but not over in this term, so we can't factor the 2 out. There's a 5 here, a single 5 here, and there's a single 5 here. We can factor a single 5 all the way out front because there's only a single one in this term. There are 2 a's here and 3 a's here, so what's common to both are 2 a's, 2 of those a's. So we can factor 2 of the a's way out front and then put parentheses and look at what's left. So we factored the 5, a times a out front. That's right here, 5 times a times a. Let's cross that out. We're just left with the 2. That 2 goes right here. Minus in the middle. Now here we have 5 times a times a. We've got 5 times a times a, so imagine all of this has been crossed out, and we still have the 5 here and the a here left. Now what we're going to do here in this next step is just clean up. This is 5, a times a is a squared. And then I just copied this down, 2 minus 5a. There's really nothing else we can do here except for to check our work. We can just, this is multiplication over addition. Subtraction is really addition if you view it right. So 5a squared times 2. 2 times 5 is 10a squared. Check. Minus, and then this 5a squared times 5a. 5 times 5 is 25. A squared means we have 2 a's. This means we have an additional a, so we really have a cubed. So we get this 25a cubed. So it really helps to check your factoring. Probably get more points on a test if you do so. And it helps you understand how to factor better, meaning that in the long run, you'll probably spend less time on the factoring problems in this class. Anybody have any questions on this particular topic? Yes, I'm referring to objective 1 in the ALEKS program. It's review part 1. Yes, yes. So that is due Sunday night. I'm just going to circle that in my notes. So anybody have any questions on this current topic, or that is the topic we just did? So I'll go on. So I printed this out of ALEKS. I wanted to show you, I know factoring's is a difficult topic, but I promise you it really helps because we can do a lot of cancellation and and learn a lot more about what can be done in math by being able to cancel correctly. You cancel factors, you can't cancel terms, even though no matter if it's how tempting it is, it doesn't work that way. I wanted to do a problem out of ALEKS, this last topic. Is it the last topic? Yeah, no, I have one more after this. I just decided at the last minute to do it, and I didn't have time to rescan everything, so or to deal with all of that. So I have one more after this. But with factoring is one of those, let's say, I could call it an objective, but it's one of those, or topic. It's one of those topics that different things work for different students. So my method of factoring is very similar to this, but I wanted to show you how ALEKS presents it, because I want you to see the connection between the way I do it and the way ALEKS does it. So let's talk about factoring a quadratic with leading coefficient 1. Now, what is a leading coefficient? Well, first of all, you will notice that this quadratic expression is written in descending power order. What does that mean? The highest exponent, the term with the highest exponent goes first. This y really has a 1 on it as an exponent. So the term with an exponent of 2 goes first, then the term with an understood exponent of 1 goes, and then the constant term is last. This is in descending power order. You want to make sure when you're talking about quadratic expressions and you're asked to factor them, that they are in descending power order. I don't think you're going to have any issues early on in the course with it, but I just wanted to throw that out there anyway. So what we are attempting to do when we factor is write y squared minus 8y plus 12 has the product of two factors. Factors are multiplied. There's an understood multiplication symbol here. So what on earth do we do? We are looking, and we're going to verify this process at the end that it worked. We're looking for two numbers which multiply to give us 12. Why 12? Because you want to look at you're looking for two numbers that multiply together to give you the numbers on the outside multiplied together. So in this situation, we have 1 times 12. Those are the outside numbers. -8 is the inside number. So we're looking for two numbers which multiply to give us 12. So I did that, got 12 by multiplying the outside numbers together and understood 1 times 12. So it's the outside numbers that you want to multiply together. And let me start just to make sure it's clear. Looking for two numbers which multiply to give us 12 and add to give us this coefficient, this in the middle. We don't want the variable. The coefficient, -8. So ALEKS is going to present it this way. I'm not sure if they do it 100% time in all of them, but I've seen it a lot. So I wanted to present it so you had some idea of when you look at the learning page, what you are seeing. ALEKS has really great learning pages. Sometimes they have another explanation down near the bottom. So if you don't like the first one and there's another explanation, you might want to click on that one. They don't have another explanation for all problems. So what we are looking for are two numbers to give us 12. So that's this M and what ALEKS is calling M and N. Certainly 1 times 12 gives us 12. And then what are we going to do? We're going to add those M plus N together. 1 plus 12, so you take the M plus the N and get 1 plus 12, which is 13. This number in the middle is not 13, so we have to go on. So all we're doing here is we're taking these two numbers and putting the opposite signs on them to get -1 and -12. When we add those two together, we get -1 plus -12. That's -13. That's not -8. So we're done with the number 1. Let's see if, so now we're going to move up to 2. We want two numbers which multiply to give us 12. So 2 times what is 12? 2 times 6 is 12. If we add 2 and 6 together, we get 8. That's not 8. That's not -8, but we're really, really close to that. We are so close, except we have the opposite sign, which in a sense is quite really off, but we're close in one way and not close in another way. So change the sign on these guys. So the 2 becomes -2. The 6 becomes -6. Now, -2 plus -6 is -8. Is that what we want? And the answer is yes. These are the two numbers that we are looking for. So how do we write this? They're telling us really that we want 2 sets of parentheses. So let's go down here, and we want to, this is what we want to factor. Just copy down here. So by FOIL, this, and also looking at y squared, we can write this y squared is really y times y. We put a y in the first position in the first factor and in the first position of the second factor. Now we look at these numbers, and we're essentially putting -2, but we're writing it as -2 in here because adding a negative is a minus, and we really have that. And we're putting -6 in here. And that's how this trinomial factors. We have 3 terms, and therefore it's called a trinomial. That's how this trinomial factors. And we can check by foiling, which is why we did that earlier, so you'd have a little practice with that on its own. The first two, y squared, check. The outer two, y times -6, which is -6y. The inner two, -2y, -6y plus a -2y. -6 plus a -2 is -8. And what -8 of what? Y. And then we have the last two. Negative times a negative is a positive. 2 times 6 is 12. So we know we've got the right factorization here. Anybody have any questions? So I try to present that as close to how I do it, or how I will do it. It's really very, very similar. It's just, I think, the M and the N that throw the students. And I'm hoping that that doesn't happen this fall semester. I'm always trying to figure out better ways to explain what's going on. Okay. So let's go on. And I have one more topic to finish up this objective, and I'm going to have to go grab that topic. ALEKS objective 1, additional topic. Factor completely. And part of the reason why I'm throwing in a few factoring topics here is so that you've already learned and understood those topics prior to objective number 2, which has more factoring in it and more challenging factoring. So factor completely. So in the last problem, we had a understood coefficient of 1. You'll notice here we have a coefficient of 6. It's more difficult in general to factor when your leading coefficient is something other than 1. Here we have 6v squared minus 24v minus 36. And I'm looking at the 6, and I would like for anything to be able to factor that completely out front. So the question is, can we write 24 has 6 times something? In other words, is 24 divisible by 6? So if I take my calculator and go 24 divided by 6, I get a 4. So we can write, minus comes down, 24 is 6 times 4, and then I copied over the V. Copy over the minus sign, and is 36 divisible by 6? The answer is yes. I'm going to take 36 divided by 6 so I can figure out the other number. Turns out the other number is 6. So we get minus 6 times 6. So that leading coefficient, the first thing you really want to think about is to think about trying to see if you can factor that out. It'll save a lot of, it may save a lot of work for you, or save you from going down the wrong path. So I now notice that every one of these terms, we factor out of terms, terms are added. So this first term is 6b squared, plus, I can sneak a plus sign in here because this is subtraction, and subtraction sign is adding a negative. So I could put a plus sign in here, addition sign, and then view this as a negative sign. So it's adding a negative. So I could sneak a plus sign in there. So the next term is minus 6 times 4 times v. The last term is minus 6 times 6. So I could factor a 6 out of each one of these. And that's what I want to do. I wanted to keep this so you could see it, so I just copied that over again. And I want to cross a 6 out from each term. And that 6 is actually, it's still going to be somewhere. It's actually way out in front. We factored it out. It's the factoring is in some sense the reverse of distributing. And so we factored it out. And what's left? V squared minus 4v minus 6. And I put the 1 in there so we would know what two numbers we needed to multiply together. So that's what we have right now. So for a moment, I know we're going to have 6 out front. We are just going to focus on this. We just need to remember to come back and grab that 6 at the end of the problem, when we state our answer. So we're just going to focus on 1 times b squared minus 4v minus 6 now. So looking for two numbers that multiply to give us negative, to give what? These outside numbers. 1 times negative 6, which is negative 6. And add to give us this middle number, which is negative 4. So if you learn to factor another way, as long as you could write down the steps, I have no problem. There are so many methods the world over. I've had foreign students show me different ways to do it. And I'm amazed at the creativity that there exists in the world for factoring. So we want to start by looking for factors of 6. We want to look for two numbers that multiply to give us negative 6. So we're looking for factors of negative 6, really. So let's start with 1. We can write negative 6 has 1 times negative 6. If we add those together, 1 plus negative 6 is negative 5. Negative 5 is not what we want to get here. We want to get negative 4. Now let's change the signs. 1 is positive here. Let's make it, the opposite sign is negative. So let's make this negative 1. The opposite of negative is positive. Let's make this positive 6. When we add those together, negative 1 plus 6, we get 5. That is not negative 4. Keep going. Let's look at 2. So we want to write, we're looking for two numbers that multiply to give us negative 6. So 2 times what is negative 6? Negative 3. 2 plus negative 3 is negative 1. That's not negative 4. Change the signs on change the sign on this 2 to get negative 2. Change the sign on this negative 3 to get positive 3. Add those two together. Negative 2 plus 3 is really 3 minus 2, which is 1. That's not equal to negative 4. So let's see what we can do now and why we're done. So we're looking for two numbers that give us negative 6. Well, if we went up from 2, we would go to 3. We've already dealt with 3 in this column. And if we went up to 4, what am I going to multiply 4 by to get 6? And they have to be nice integers to do that. There isn't anything, so I don't need to do that. Well, what about 5? Same response. 5. There's no nice number that I can multiply 5 by to get 6. So I know I'm done. Now, what do we want in this column? We want to have a negative 4. Do we have a negative 4? The answer is no. So we cannot factor this piece right here. It doesn't factor more. I will tell you in this particular ALEKS topic, some of these will have trinomials here that factor more. Some of the questions will not. You will stop. I wanted to make sure I showed you one where you will stop and talk about how you know when that, how you are. I want you to be able to convince yourself why you stop, why you can't go any further. I don't want you to sit there and, and start trying to figure out how to factor this when it can't be factored. So I really wanted to show you one of these. Any questions? That's why I chose to have this additional topic. And I will put my notes in ALEKS and tell you how to access them. I'm running a little bit behind because I have so much that I want to do and have done this week. It's been a really busy week, probably the busiest start to the fall semester that I've ever had, because it is so different. Anybody have any questions on this topic or this objective since we are finished with objective number 1?
I actually have a quick question.
Yeah, sure.
It might be a dumb question, but I'm a little confused.
I'm not looking at it like that. I want you to understand, because sometimes asking those kind of questions helps us connect in our minds things better, figure it out, and then we can do a lot more. So what is your question?
I'm a little confused why we crossed out. I get it over time, like why would we cross out those 3 6s in like the second step?
Okay, very good question. Because we're wanting to factor, which means we want to write as a product. Okay, we want to factor. So you're wanting to know this, why cross these out?
Yeah, I guess I'm just confused why it went from 3 6s to 1 6. I guess that's
okay,
tripping
because
me.
they want us to factor. So right now this is written as the sum of terms. Terms are added, so I could really put a plus sign in here. Coincidentally, what I've got is a plus sign. That's really funny. I'm working in this Acrobat reader. I really have found that I like this, but there's this plus sign, for like a pointer here or whatever. So there's really, you could sneak a plus sign in because subtraction is adding a negative.
Oh, okay, that makes sense.
And so we're talking about terms. So the way this is expressed or given to us originally in this problem is as terms. And so we want to factor, which means we want to write as a product. So that's why we want to write the whole thing as a product. That's
Okay.
why factoring. Does that answer your question?
Yes, thank you.
You're welcome. Anybody else have any questions before we go to the next objective and get started on that? Okay, so I'm going to go and get that document. I'm trying to keep these in a nice, so I can put these in the software, and I will notify you when new documents have been put in, ALEKS, for you. So I want to go and go down to Finder here, and let's take a look at ALEKS Objective 2. So Objective 2 review part 2. Let's talk about this. And the beginning part might actually help you understand some of the terminology. I had a student in my last class, she's like, I've been out of school for like 15 years, and I think what's difficult for me is understanding the terminology. ALEKS has a dictionary available in every topic, which is nice. And on the learning pages, they have places where you can click on words to find out what they mean. So, and I'm talking math words, so that's good. So to factor means to write as a product. And this is a nice segue into what I was just talking about a few moments ago. Factors are multiplied. So we're going to talk about terms and factors and terms here. Factors are multiplied. So there's an understood multiplication symbol in there. So what are the factors? X minus 3 is a factor, and also this 2x plus 5 is a factor. So those are the factors. Terms, on the other hand, are added. Factors we can often cancel out. If you have a factor in the numerator and a factor in the denominator, you can cancel them out if they're because they participate in multiplication and they stand for real numbers. So like 3 divided by 3 is 1. That's why we can cancel them out. Terms we can't cancel out. So unless you have a single term in numerator and denominator. So we really can't, and in that case, you could technically view it as a factor. So I don't want to get to the nitty-gritty of that, but terms are added. And so we've got x plus 3 plus 2x plus 5. If you put parentheses around x minus 3 and 2x plus 5, you can then see they're now being added. We could then call x minus 3 and also 2x plus 5. We can consider them to be terms. Why is this important? We factor out of terms. Why do we factor out of terms? Because we can cancel factors, not terms. That's why we spend so much time in algebra courses working on factoring, because we can cancel factors. And actually it helps us be able to do a lot more algebra if we know how to factor. So this is an overall factoring strategy, and let's go over this a bit. It's really hard to write down steps for all the factoring processes because there are so many of them, and they can get so technical, but I will do my best to let you know what to do. So what I want to talk about is we are going to see, you're going to be asked to factor problems which have 2 terms, 3 terms, 4 terms, and 4 terms. But in the last problem, I want to mention the last problem. We saw how important it was to factor out that 6 first, correct? Well, I think it was the last problem that we did, where we factored out that 6 first. The very first step of a factoring problem is to look to see if all of your terms have a common factor. And in particular, they could have more than one common factor. If they do, you want to factor that as much, whatever the largest common factor is out first. So you might see a 4 and a 2 in each factor being multiplied, and they have to be multiplied, like a 4 times 2 in each factor. So you can factor, if you do, you can factor that 4 times 2 way out front. That's always the first thing you want to do, but it isn't, you're not always given a problem where you can factor a number out of each term. I suppose you can technically say you can factor a 1 out of that, but of each term, but if you have a 1 times something, it's that something, so it's not really, we don't really do that. So after you've factored out the greatest common factor, let's go in order. Let's look at 2 terms. Now the first thing I want to do is look at this. We've got 2 terms. We've got an ace. We've got, on this side, we only have 2 terms. We can put a plus sign right in there, and we have a squared plus a negative b squared terms are added, so our terms are a squared and negative b squared. So we have 2 terms. There are different ways to factor this, but we actually have a formula for it. That's what this is. So if you have a number squared minus or it could be a variable or a number squared, minus a variable or a number squared, and you have nothing else, nothing out here, nothing out there, you can use this formula to factor that expression. And how do you do that? Well, this a is the base of this square, so you just get whatever the base of that square, the base of that number 2 is, and write it down, plus whatever the base of this 2 is, which happens to be b, and write it down. And then you just copy it over and change the sign from a plus sign to a minus sign in the middle. Now, why does that work? Or how do I know that's correct? Or how can I prove that this is correct? We could FOIL. We've got 2 terms. FOILing only works when you have 2 terms times 2 terms. There's really a plus sign right here. So we really have 2 terms in the first and 2 terms in the second. So I'm going to FOIL this to prove that we get back this. A times A. The first 2, FOIL F4 first. The first 2 is A times A is A squared. A times A is A squared. Check. Then the outer 2, these 2, we've got a negative sign, so it's really negative A times B. The inner 2, it's really plus BA, but we can switch the order of multiplication because it's commutative. Multiplication is commutative. So we have the O, which gave us negative AB, and the inner here, which gave us positive AB. So the negative of the same as the positive is 0. And then we have to just look at the last 2 here, which is negative b times b is b squared. So that's where the negative b squared is coming from. So it's really a very, very good, and you can only use this formula when you have the difference of 2 squares. You must have 2 terms and you must have the difference of 2 squares to use it. Now going on, let's step it up and talk about 3 terms. Well, we've already started to talk about 3 terms already. There was the ALEKS method. There's the method that I use, which is called the AC method, which ALEKS is really using too. That's where their M and their N are. Instead of calling it AC, they're calling it MN. Is really what they're doing. So I'm given a trinomial here and I want to factor it. I'm going to make the leading coefficient A. Coefficients are multiplied. That's the number in front. Could be 1 for you, but we saw 6 already, so it could be something other than 1. this B, remember what's that number that's in the middle? That's what we're looking for over here, right? When we were doing the ALEKS method, it's still true the way I do it. And then the C also goes, those outside numbers go in the first column, the A and the C. And you can include the signs. So for instance, you include negatives if you have a negative. So we'll see some more examples to that. It's really difficult to write out. It gets very wordy if I try to write out a complete process there in words, and I don't really want to do that. For terms, factor by grouping, pair off terms so that only a plus sign shows in the middle. And by pair, I mean have two together in one set of parentheses and have the other two together in the other set of parentheses, and you have a plus sign showing in the middle. So there are some other topics in here besides factoring. I chose to put this one in because I wanted you to have a little practice with square roots in the previous objective, in the first objective, before doing this one. So where this comes up is in the quadratic formula, being able to simplify expressions such as this. So if you have a quadratic equation set equal to 0, the two main ways of factoring that are, one, trying to factor it by the AC method or the ALEKS method, or two, using the quadratic formula. And in the quadratic formula, quite often factoring comes up in it as well. So you will need to know how to factor to solve quadratic equations. And in the Start Here assignment in Canvas, I gave you a problem which asks you to solve using the quadratic formula. So we will be getting to quadratic equations before the first test. So let's take a look at this. I am just checking our time here just to see where we're at. Okay. We want to simplify this expression. So break the job down. Let's just take a look at the square root of 20 and see what we can do with it. So square root of 20, how can I break that down? In other words, how can I break the number 20 down into factors? Well, 20 is 2 times 10, but it's also 4 times 5. And you can go either route, really. So 20 is 4 times 5. We know the square root of 4. What's the square root of 4? Anybody remember what it is? It is
2.
2. So we can bring out the square root of 4 as 2. Yes. And can we do anything with this 5? Does it have a nice square root? Can we take the square root of 5? And the answer is no. So we take the square root of 4 out as a 2, and we leave the 5 inside. So that's how it simplifies. So let me just copy this over, but that's what I did, except I replaced the square root of 20 with 2 root 5. So the square root of 20, I guess let's back up for a moment. 18 goes down here, minus square root of 20 is 2 root 5, and then divided by 2. Now, I cannot cancel these 2. Doesn't work. Why is that? What's going on in the numerator? We have 18 plus a negative 2 square root of 5. We have 18 as a term, plus sign. So 18 and minus 2 root 5 are terms. We can't cancel terms. Cancel factors, not terms. We can't cancel terms. This 2 is participating in a term. We cannot cancel this 2 with this 2. You will not get the right answer. If I cancel these 2's here, we'd get 18 minus square root of 5. 18 minus square root of 5 is not the correct answer. So we can't do that. But what we can do is see if we can write this 18 as 2 times something. And we can write 18 as 2 times 9. And what we can do now is this is a term plus negative 2 square root of 5 is a term, so we can factor out of these terms. We can factor 2 out of each of these terms. So let's factor a 2 way out front. So if we factor a 2 way out front, this 2 is going out front, this 2 is going out front. And just so you know that I'm not, and we are left with, if this 2 goes out front, we're left with a 9. This 2 goes out front, we're left with minus square root of 5. Now, what if we would go backwards? 2 times 9 and 2 times negative 5 is negative 2 root 5. So I know I've done the right thing. Now we've got a 2 here and a 2 here. We can cancel those 2's. Why can we cancel them? 2 divided by 2 is what? It's 1, right? And 1 times what's left is what's left. So what's left is 9 minus square root of 5. And that is the answer. So we can cancel factors, not terms. Factors are multiplied. Terms are added. That's why there's a difference there. Any questions on this particular question? This given in ALEKS? Now let's take a look at another one of these. I want to make sure you're all good with simplifying these. You will definitely see this in the quadratic formula. They may have the square root of 50 might be on this side, but it's very similar to what you would see in the quadratic formula. How do we simplify the square root of 50? Well, how can we rewrite the number 50? Well, a 2 goes, right? 50 is even. So it's 2 times 50 divided by 2 is 25. And I don't know why I copied this over again, but I did. So let's just go there. And what's the square root of 25? What number times itself gives us 25? It would be 5, right? So we can take out this 25 as 5. But we're left with this lonely 2 here inside the square root. So what are we going to do? We're going to take out this 50 here, let me take it, the square root of 50, and we're going to replace it, the square root of 50, we are going to replace it by 5 root 2, so we get 5 root 2 here. Minus, while I'm at it, I'm going to break down 25. Why am I going to do that? Because I see a 5 here and a 5 here. So I'm going to write this minus 25 as minus 5 times 5 divided by 5. Now, here's where the factoring comes into play. You have, I'll put a plus sign there. You've got 2 terms there. 5 root 2 and negative 5 times 5. Those are terms that are added. So we want to factor out of terms. We want to factor out of 5. All the way out front. If we take a 5 out of each term, what's going to happen? We took a 5 out of this term. We're left with square root of 2. Minus sign. We took a 5 way out front here. We're left with just a 5. So this is what we have. And then divide it by this 5. Again, 5 divided by 5, if you do it on your calculator, it's 1. 5 divided by 5 is 1. And 1 times what's left is what's left, which is square root of 2 minus 5. And that is the answer. So any questions on these expressions that you'll see similar ones to in the quadratic formula? And that's coming up in the next few objectives. important. Let me just kind of check back in with you and take a little breather. Anybody have any questions? I might ask you all to like bring a joke of the day and assign everybody a day in the class or something. I don't know, I might ask you for, I may come up with I was thinking about, in my earlier class today, they were chatting, which is fine as long as you're using the chat for productive things related to this class. If it gets to be more, I feel like it's becoming distracting, that I don't want, but if you already know a topic and you're trying to help out another student, all the better. So then this led to me maybe creating a Microsoft form that I could place in the chat that you all could fill out really fast to see if you would be interested in forming virtual study groups to work together outside of class. And you're more than welcome to come to my virtual office hours, which I will definitely be posting this weekend and sending you out an email about, or sending you and then notifying you that when I've done so. And so I'm going to be very busy, but what I'd like to do, if you're interested, and I'm going to do it for my earlier ALEKS class today, is have a Microsoft form to see if you would be interested in forming some kind of study groups. And on that form, I'm not just going to have, are you interested? I was thinking about having some times like available weekends, available nights, available, afternoons, whatever, so that we could kind of begin to go down a path of trying to match students up with who may have similar times available. Is anybody interested in that in this course? If you are, can you just please raise your hands really fast? Those that are interested, might be the fastest way to raise their hand so I can kind of gauge how many of you are interested in forming study groups or being able to reach out to others. Okay. So if you are, let me know later. Just maybe you're all so busy you haven't really have too much time. And I know how that is. I'm so busy too. So I just wanted to take a little break there. Let's go on and see. So now we're getting into some more factoring. We're getting into how many, and this really, the method depends on how many terms you have. The method you choose depends on how many terms you have. And then you may be choosing, there may be multiple methods after that you have, depending on how many terms you have. And that's what makes factoring pretty difficult, because different people do it different ways, and you may have seen it different ways in the past, and then along comes a teacher that presents it yet another way, and so forth. So let's see how many terms we have here. Well, you can see 2 terms, but why? So remember terms are added. So I could sneak this plus sign right in here. So our first term is z squared. So if I stick this plus sign in here, terms are added. The second term is -16. So we really have 2 terms. Now there's different ways to do this. You could actually do it this way, which is the AC method. And however, you may not want to do that, but let's look at another way. Remember, I had put this up earlier when we were talking about a factoring strategy. Let's look at that. And I'm just making sure we've got z squared minus 16. Yes, we do. So this is the factoring formula. I just wrote it down when you have 2 terms. So I'm hoping it works, right? So what is our A and what is our B? In order to use this formula to go in this direction, we need to identify A and B. What is our A and our B? So A is what's beneath the square in the first term. What's beneath the square and what we're given? The Z. So A is Z. What's beneath this square? Well, we should probably rewrite this. How can we rewrite 16? So this is not, this negative sign is in the middle. It's not part of this 16. Negative sign is in the middle. So how can we rewrite 16? 16 is, break it down into factors. There we go with factoring numbers. We've done so much factoring today. We're not only factoring expressions, we're factoring numbers. Lots of factoring. So 16 is really 4 times 4, which we can write as 4 squared. That means we have two 4s multiplied together. So what's our B? It's what's beneath our second square in the problem. It's what's after the minus sign, too. You have to have it after the minus sign. It's what's beneath our second square. So that is our second, I should say, exponent of 2. That's another way to put it. So what's beneath that is 4. So B is 4. I do want to mention that this represents a negative sign. So a negative sign, you can write a negative has a -1. So you could put in a 1 here. So that 1 would make sure that I hope that you understand that that negative sign is not part of the 4. We could put a -1 in here. A negative is just a -1. So we could put a -1 in here, and that would show you that that's a -1, not a -16. It's actually your work with this is a positive 16 to get this 4 squared. So our A is 7, our B is 4. We just plug into our formula now to factor, our factoring formula, which is right here. And we plug in Z for A here and here. We plug in 4 for B here and here. And that gives us Z plus 4 times Z minus 4. So that's one way to do the problem. And I wish I had with factoring, there's so many ways to do so many of the problems. I'm thinking that's one reason why students may find it somewhat difficult and challenging. Any questions on this particular problem? This is the difference of 2 squares because we have a 2, which is also called a square on the Z, and we really have a difference, and we can write 16 as 4 squared. So it's called the difference of 2 squares formula. Anybody have any questions? I'm all about questions. I've got time today for questions.
I have a question over a definition. What does commutative mean?
Commutative?
Oh, yes, ma'am.
Yes. So if you could, so commutative, so multiplication and addition are commutative because you can switch the order of that you add or that you multiply. Does that mean? Is that what you're saying? So that means basically a commutative property is one where you can switch the order of what you do. You can switch the order of numbers you add and still get the same answer, or numbers you multiply instead still get the same answer. So like 6 times 3 is 3 times 6. And 6 plus 3 is the same answer as 3 plus 6. Does that answer your question?
Yes, ma'am. That helped a lot.
No questions are too small. What other questions do you have, or other ideas about how you can all connect with me or with each other? Because I think it's really important since we have a remote class. And also, the way I ran my ALEKS classes in the past, or have run them, is giving students lab time. And unfortunately, we don't have a great way remotely to do that. So I'm looking for other ways for students to connect. Any other questions? Yes,
I have a question. So if we're doing like our little modules on ALEKS and we come across a problem, all we have to do is email you, or Or do we wait for your office hours?
So let's go into ALEKS right now, and I want to make sure I show you all something. So let me just go into ALEKS. So it'll take me, it seems so funny that I have to actually go down to my desktop and click on Google to get back. I have to go from the internet down to my desktop and back up to the internet. So let me show you. Let's see. I have to make my screen pretty big for session timed out. Log in again. Okay, so and I'm going to just start by, I'm jotting down another item I want to mention to you. So, okay, so if I want to make sure, I don't know if all of you heard me, I did talk a bit about this, I believe the first day, but let me go back out. These three bars, there's a lot going, this main menu, this is ALEKS's main menu, and there's a lot going on here. So the home screen is the pie screen. Learn, that's where you're going to learn your topics. So if you clicked on review part 1 here, start my path, it's going to take you into learn mode. So you can get to learn this way too. Review, so when you've learned a topic, it will go into review mode. Now, it's possible on the knowledge checks that you could unlearn topics and they could go back here. So just so you know. Assignments. So this is what I've done, and I've just not done very much here. But if you're in doubt whether you've completed an objective, you can go to assignments and take a look. You should, if you have it 100% here, then you have completed the objective. So I wanted to show you that. I am going to bless the calendar this weekend. I just want to make sure I've got the date, I wanted to confirm those test dates, the testing window dates and so forth, or not the dates, but the testing window times for y'all. And I did that today. So I'm going to bless that this weekend, and I will send it out when the calendar is ready. So you can look at that, because the ALEKS calendar is quite wonderful. Let me just click on it just to mention something though. You see the start here, assignment. That was due on the 26th. The truth is, I think you can still work on it, because I haven't prevented students from working on it by setting a due date in Canvas, because I want all students to do that. That's worth like 18 points of your grade. And you don't want to lose those points. So you need to complete the entire assignment to get those 18 points, and you need to complete that assignment really to get to ALEKS anyway. So now this review part 1 is due on the 28th. And if I click on it, it tells you for sure it's due tomorrow and what the due time is. So what I'm saying is, this strip is where the objective due dates are. This strip is where assignments that I have created appear. So if you want to really know what's going on a date, you really have to look all the way down for say, August 28th, like this. So I want to show you how to use the calendar. I wanted to show you how to use the calendar since I'm here. The grade book is where you're going to go to see how you're doing in this course, like your grades on scores on your exams and so forth. What's going on in assignments isn't always accurate. So you want to make sure you're going to the grade book. There may be times when you want to use reports. There are creative ways to use reports to look at knowledge check results. There's a message center, instructor resources. This is where I will be putting the class notes. I've got some videos in here. I've got an ALEKS navigation video that I created. It isn't for this particular term or this particular class, but it's basically it's still, there's lots of valuable information in there. Now to get to your question, let's go to learn mode. And I'm going to click on explanation. And I'm just going to look to see. Okay, so this is what we went over today. But let's say you've got a question. So over here on the far right, you will see resources. These are instructor resources. Actually, they're good ALEKS videos that I found from Arizona State University. They have a big global online program, and they teach their courses with some of their courses with ALEKS. They have created really good ALEKS videos. So I put those in the course there. And that calculator is sometimes available, sometimes not, which is why I want you all to purchase a graphing calculator. If you can do the problems and show your work without it, I don't think you can really. So you want to be able to show written work you're required to show written work for 7 problems on each exam. So you may want to you really want the graphing calculator available when ALEKS doesn't have their calculator available. These are some videos that come with the e-book, the e-textbook. They have been created by the author of the book. This is the e-book. This is the dictionary. So if you don't know a term, you can look it up in the dictionary and to see what it means. And there are lots of links on various ALEKS pages, learning pages to definitions too. So keep your eyes open for those. This is what I want to click on, the envelope icon. And what you notice is it attached this page, factoring a quadratic with leading coefficient 1. It automatically attached the problem that we just had opened up, the exact problem. Now, I encourage you to, when you send me a problem, you have the ability to attach written work here. And I would like you to do that because it's in the long run a quicker way for me to help students when I can see their work, and then I also know where the student tends to have difficulty on the problem. Just emailing me a problem and not giving me any information about where you need help, I'm not even sure where to start, and I need a good starting point. So I ask that you all try to help me help you by giving me as much information, including written work, so I can pinpoint where your issue lies. I want to know where your first issue is so I can help you. And so I hope that answers your question. And there are some various icons over here that you can, like algebra, if I click on there, there's quite a few icons there. So I want to ask, did that help the explanation of ALEKS there? Did that help y'all?
Absolutely. So just to clarify, because someone else asked this too, the review's due Sunday, right?
What was your question? I'm having a little hard time hearing you.
Sorry, the review is due on Sunday, correct?
The review is due on Sunday. Yes, review part 1. Yes. Let's see. That is correct. I don't want to wait until Tuesday of next week. I think that's too long. I really, really, really want you to get it done by then, because I think the longer you go without doing it, I don't want it to be 5 days down away, because what's going to happen as the semester goes along is you're going to be required to do at least 2 objectives per week. And you may have other assignments to do, and you may have a knowledge check pop up. It's going to get more, there's going to be more to do in this course. It's just because we're getting started. So yes, Sunday I think is good for this. I think the first group of topics isn't too challenging. It's this second group of topics that we've been working on today that are more challenging. Okay, so I think I agree with I think I'm good with the Sunday. I don't want to move it out anymore. Does that make sense? Yes? No? I don't want to move it out anymore. Yeah. I want to have the good pace going on in the course. I don't want to get to the end of the semester and like, oh, you've got 10 objectives to do in a week, or 10 objectives due in 2 weeks. I don't want to do that to you. So yeah. Okay. Any other questions? I love chatting with you all. Any other questions about any part of the course? Or yes, Sunday by 11:59 p.m. I can't go in then change it right now. I'll change it as soon as if it needs to be changed, I will change it right after class. Any other questions? Okay, so we took a little break there just to chat about something else. So let's go back and look here. So we want to factor completely. And I picked this problem because not only will it give us more factoring, another factoring example or more practice, there's a negative in front here, as well as that we have a negative leading coefficient, which is not -1 even. So there's a couple of reasons why I picked this problem. We have 3 terms here. Terms are added. So we've got -3u squared plus the term -4u, and then we've got the term 4. So when we have 3 terms, we really need to look at the factoring those 3 terms, which we can do by the MN method of ALEKS or the very similar AC method that I've been presenting. So let's do this one by the AC method. So I'm copying this down, -3u squared. I copied this down, -4u. And then I chose to write +4 as +1 times 4. I think that the reason will become clear. Every one of this negative sign by itself is really -1. This negative sign is really -1. I knew we would be talking about 1s, so I chose to write this 4 as 1 times 4. So I knew we would be talking about -1s, so we better put 1s in, and the only one we can put in here for 4, we can't put a -1. We can put a +1 though. I can show you how we can get negative. We're going to look at how we can get -1s in a moment. Okay, so every negative sign in math really represents a -1. So let's replace this negative sign with -1. Copy down 3u squared plus this negative sign is -1. So I wrote it as -1 times 4u plus, now I want a -1 here. So how can I get it? Well, the number 1 is -1 times -1. because that gives us a positive 1. So I wrote down -1 times -1. That gives us a positive 1. So that's the way I wrote it, and I wanted that a -1 here because I have a -1 in this term and in this term, so I want a 1 in this term. So let's factor out a -1. That means we're going to take out a -1 from each and every term here, and we are able to do so. So if we take a -1 out of the first term, we're going to cross that guy out. In the second term, we're going to cross that guy out. And in the third term, we're going to cross one of the -1s out. Well, what's left? So in this first term, 3u squared is left, plus 4u is left, plus a -1 times 4 is a -4, plus a -4 is really -4. So the good news is we don't have to, we can just leave this -1 here for a while and work on this. We'll have to come back in our final answer and put a negative in front of it though. So let's look at 3u squared plus 4u minus 4. We want to factor that. So we're looking for two numbers, right? That multiply to give us these outside numbers, the outer numbers. So we were looking at 3 times -4, which is -12. So they multiply to give us -12 and add to give us this number in the middle, which is +4, which we can write as just 4. So you're welcome to start with wherever you think makes sense here. I'm thinking, I look at this -12 and I'm just going to say, okay, well, I can write that as two numbers as -1 times 12. And -1 times 12 multiplies to give -12. I like double check that. I would encourage you to do that. Now when the double checking is really important. It really saves time in the long run. So then we look at -1 plus 12. So that's the same as taking 12 and subtracting 1, and it's 11. That is not what we want. We want 4. That's our goal right there. So now what if we have -2? You can have -2. -2 times what equals 12? 6. Now if we add these two together, -2 plus 6 is really 6 minus 2, which is 4. That is definitely what we want here. So we want to use these two numbers to break down or split. You could say break down the middle 4, or you could say split the middle term. So we want to write this as we want to write 4u as using -2 and 6. So we're going to take this, so we have this term plus this term plus -4, which is a term. We're going to use this 4, no, sorry, we're going to use this -2 times 6. We're going to use those -2 and 6 to split this middle term, if you will, split this 4. So if you notice, I split it into -2. -2 of what? U. And then also plus 6. Plus 6 of what? U. Then I put parentheses around each pair of terms so that only a plus sign shows in the middle. And that's the strategy for 4 terms, which was on that strategy document, or that I presented earlier. So now what we want to do is we want to factor out of each pair of terms. Here's the first pair. So the only thing that this term here and this term here have in common is a u. So we want to factor a u out in front. When we factor a single u out, we're still left with a u. In fact, we're left with 3u inside. Minus. We're factoring out a u, so we have a -2, and that u went out front. And then plus. So what I did up here is I took the 6 and lightly crossed it out and replaced it by 2 times 3 because that is 6. And then I took crossed out the 4 and replaced 4 by 2 times 2 because 2 times 2 is 4. What I'm trying to do is get some commonality here. Figure out what they've got in common. And make sure I figure out the most they have in common. So I can now see that this term here, this term with the u here, and this term with the u here, both have a 2 in them. So I'm going to cross out the 2 here and here. And what am I left with? Is the question. So after we've got the 6 has been crossed out because it was replaced by something else, the 2 has been crossed out, we're left with a 3u. That goes right here. And let me make sure. No, it goes right here. Sorry. That goes right here. It will go right there in a moment, but it goes right here. And then what's left? Yes. Let me make sure I've explained this in my head to you all. So we took a 2 out. We get just a 3u left here. And just to make sure I've covered all my bases, we get a -2 left here.
Okay, I have a question.
Yes.
So at the top where it says factor and it's 3u squared plus 4u minus 4. Not at the top, but like in the middle, sorry. When you factor out that 4, the 4 in the middle, where did you get?
I'm trying to figure out where you are.
It's right in the middle.
Is it here?
Right here, yeah, where it says factor, and then it has the 3u squared plus the 4u minus the 4. Okay, where did you break that 4 down into the -2u? Then, because you took that.
Those numbers came right from here. Those numbers came right from here. Okay, so when we factor, we're looking for 2 numbers that multiply to give us this number. How do we get this number? If you have any similar problems to this, how do you get this number? You take these numbers on the outside, 3 and -4, and multiply them together. So that's -12.
Okay, awesome.
And you want 2 numbers that not only multiply to give you these outside numbers, you want these 2 numbers to add to give you this inside number, which is +4, which is where this came from. Does that make sense? Or do you understand where these numbers came from?
Yes, I do. Thank you.
Okay. So let's go back here. So I believe we were at this step. So what you notice here, you've got a term here. Terms are added. So we know that this is a term because there's a plus sign here, and this is a term. So we factor out of terms. So in this term, we see a 3u minus 2, and in this term, we see a 3u minus 2. So we can factor that out here. We can factor that out as a 1 out front. We're factoring that out front. Well, what's left? I lightly cross these out. What's left is this u plus 2. So that goes in this other factor. Now, are we done? No, remember we started this problem, even though it seems like a while ago, we factored out a -1. We still have to make that, put that out in front, and that's the reason for the negative sign out in front. Anybody have any questions on this problem? This is why I've learned to teach this way, and I taught several classes this summer online, is so that you had the opportunity to tell me, help me pinpoint your problem by going right to a step on a document we could talk about. So anybody else have any questions on here? Are you sure? I'm here for you. I want you to ask me questions. Are you following? Does it make sense?
I'm kind of confused on where the U came from in the front.
The U came from?
Like
down, up, okay. Up further?
No, right here after we
There?
after the 6 and the 4.
The 6 and the 4.
Where it was like 2 times 3 and then 2 times 2. And then we went.
Wait a second. 2 times 3 and 2 times 2. I'm just.
Oh, that U came out because, so see where she, it was 3U
let me get
squared.
to the same step. Let's get to the same step. So let me put my cursor on this, you know, like somewhere where everyone can see. So is it on the page that I'm showing right now, where we need to go?
Yes.
So is it have to do with this? Does it have to do with this?
So it's like 2 steps above the answer you circled.
Right here, or one more?
I don't know. I can't see your cursor. Oh, there it is.
Yeah, right there.
Okay. Okay, where did that U come from?
That's
okay.
on the outside.
Yes, 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 I see. Yes, so I factored out of here. What can I take out of those two terms? So we've got a 3U squared here minus 2U. So this 3U squared is really 3U times U. We've got 2U's here. So this is really 3U times U minus 2U. So there's a U in this term. There's actually 2 of them, and a U in this term. So I can factor that U out front. If I factor it out front, what do we have left? We have a 3U left because one of the U's went out way out front. And then we have minus 2 because this U went way out front. Whoops. And we can check. We can distribute this U through to see if we got, when we distribute it through, if we get back this. So this is U times 3U, which is 3U squared. Check. And then U times -2 is -2U. Check. So I know that algebraically, this right here is equivalent to this. But this will allow us to factor further. And then, yeah. Do you have a comment on that? Do you have a comment? It's okay.
No, I got it now.
Okay, that's good. I'm glad. Anybody else, or you have another question on the problem? That's what I'm here for, and I love this because this is the lab time I'm talking about, the engagement, the interaction that I'm talking about, and that I'm missing, and it's part of this course. And I think, you know, my classes today in ALEKS have really helped me. You know, we're helping each other figure this out as we go along, and I love this. So if you have any questions, please don't hesitate to ask. I want you to understand.
Where did you get the negative in the answer? So you went from 3U minus 2, like you went from those two problems in parentheses.
The negative had to do with because we did a part up here where we factored out a -1. So we got this, and so we had to remember that we had to use this negative. So we got this from doing this up here.
Right.
Then we got this for a lot of the problem, we spent factoring 3u squared plus 4u minus 4. But we still have to have this in our answer. I just didn't want to write that -1 over and over again, and I thought it would confuse the problem.
Okay, that makes sense.
Any other questions? Anybody else have any other questions? Let me see what the next one is.
I think I have a quick question.
Yeah, sure.
I guess I'm a little confused on how I think it looks like you crossed out the 3u minus 2 and like the second, third to last step, like 2 above the answer.
Here?
So it looks like you crossed out like the 3u minus 2 on like both sides. How did you end up still having a 3u minus 2, if that makes sense?
First of all, there's not both sides because we don't have an equal sign in this problem. Okay?
Yeah, I understood that. I think I was just trying to explain.
Right. So we're still wanting to factor more. See, we have terms here. We've got one term here. Terms are added. We've got a term here and a term here. So we can still factor because in this term right here, there's a 3u minus 2. And in this term right here, there's a 3u minus 2. This 3u minus 2, say, just stands for a number, say 10. This is just a way of, using these right here. This is just representing, this 3u minus 2 just represents some real number. We don't know what real number it represents. Do you see what I'm saying?
Yeah.
So this could be, say, u times 10 plus 2 times 10. And in that case, we could factor the 10 way out in front. And this would be 10 right here.
Okay.
And yes, so really does that make more sense?
Yes, thank you.
You're welcome. Other questions? Anybody else have any questions about anything having to do with the course? Well, I usually give students, sometimes in my classes, and often I gave them a break. So we're like talking about, we're at, what time is it now? It is 1:43. We have about 7 minutes left. The next problem is somewhat challenging too, and you've all been so attentive. I think I'm going to let you out early if you don't mind. Are you all good with that? Or would you like me to go on?
I'm good with that.
I'm good with that too.
Can you all raise your hands if you're good? Raise your hands if you're good with it. Can you click on the hand up here? See? You all good? Okay, well, yeah, let's just end class, and just a moment. Let me make sure I get your attendance down because I've got to keep reminding myself to do that. That's the thing. I mean, my routine has been a little, I'm just going to take screenshots. That shouldn't take me very long. You should be good. So feel free to leave and have a nice weekend. And you can welcome to click on the envelope icon in ALEKS that I just showed you a bit ago. So take care, and I'll see you on Tuesday. Have a nice weekend.
See you on Tuesday. Have a wonderful weekend.
Thank you.
Thank you.
You're welcome. You're welcome to stick around if you want to talk to me about anything. Blair, did you get your answer?
Oh, yeah. I guess I could put my hand down. Thank you. I might get a hold of you later with some questions or 80, but yeah. Okay, thank you.
You're welcome. Brian or Isabel, do you have any questions?
Hi. Yeah, I had one about like ALEKS So I went through like the initial knowledge check and everything, and like it, whenever you do that, it like puts you through like a certain percentage of like all, I guess, like all of the stuff that we're gonna go through. But I believe you said that last class, like that's what we're gonna be working on, is a part that like we didn't get, or like we didn't know.
So do you mean so ALEKS determines every student's unique knowledge state and what they need to learn based upon the topics that I have selected for the course. Is that what you mean?
Yeah, and like the grading and everything is like based off of like, obviously you said like reviews and the stuff that you put in there, but that initial knowledge check like puts you at like a certain percentage of
right.
that, correct?
So there's no credits associated with the knowledge check whatsoever.
Right.
So what that knowledge check does is it will already give you credit for certain topics and certain objectives if they have determined that you have learned that topic.
Okay.
But
So
unlearned topics in a course too, so just keep that in mind.
Right. So like I happen to do pretty good on the initial knowledge check. So like I think